Hi guys, here is a short video on how to calculate or solve basic parallel circuits. Here's my circuit. I apologize, it's not the prettiest looking circuit, but let's talk about it. So remember, in parallel circuits, your current is always flowing from the negative side of your battery terminal to the positive side. So, oops, I want to change to red. Let's change to red. So it's flowing this direction. Here comes my current. And this is going to be my I total. My IT, so that's my total current. Okay, and I want you to think about a river. And we talked about this in class for those of you that were in class. We've got a big, huge, wide river flowing, and we're going to split our river. Right? The river has options. It can flow to different streams, right? So this river, this river is going to split into three distinct. It's kind of a weird looking branch of the river, but three distinct ways. So here comes the water, it's flowing, this big flow, and some water is going to go this way, some's going to go this way, and some water is going to go this way. Water always wants to take the path of least resistance. So whichever is the easiest way for water to flow, the least number of obstacles, the least resistance, water is going to flow that way. Electricity is no different. So here let's look at Look at our parallel circuit, and I'm going to erase my river because it's taking up too much space. Maybe I can erase it faster than that. Maybe I can go like this. Ah, yes. So let's get rid of that river. So here comes our total current, and our current is going to split up into each of these three streams. You can think about it. And I'm going to just make up some numbers here. Let's say that resistor 1, oopsies. Let's see. I'm going to say, let's choose orange. Orange seems fun. Resistor 1, I'm going to say has a value of 2 ohms. And resistor 2, let's say has a value of 4 ohms. And resistor 3 is a value of 8 ohms. So 3 different resistors, 3 different values. And let's see what this looks like. Okay, so here's all our resistors. We know that our voltage is here at 12 volts, and we know that our current is going to break apart. So some of our current is going to go this way, and I'm going to call that I1. So that's an unknown. We don't know how much current is going to go that way. Some of our current is going to go this way, I2, and some of our current is going to go this way. So a couple of different ways to solve this, but we're going to go through kind of the standard approach here. So when we talk about any basic circuit, we're almost always going to be using Ohm's law. So V equals IR. Remember, we can rearrange this equation several different ways. In this case, the one thing we don't know is the current, so we're going to rearrange it. We're going to divide both sides by R. And we're going to have the equation I, current, is equal to voltage divided by resistance. Okay? And remember, this resistance is our RT, our total resistance. And we got to figure out what our total resistance is. So when we have circuits that are in parallel, our total resistance is, it's kind of an interesting equation, and I already screwed it up here. Let me delete that and try again. So our equation is going to look a little odd, but don't worry, it's not too bad. Our equation is going to look like this: 1 divided by R total, so the inverse of R total, is going to be equal to the inverse of all of our resistors added up. Okay, so I know that looks a little strange, it might look a little intimidating, but it's really not so bad. So when we go to solve for our R total, we're just going to plug in the values of each of our resistors. So in this case, R1 is 2 ohms, so 1 divided by 2. R2 is 4 ohms, so 1 divided by 4. And R3 is 8 ohms, or 1 divided by 8. Remember, the current is going to take the path of least resistance, so we expect the most current to be going here through R1 because it has the lowest resistance value of 2 amps. So if we add these up, we're going to find a common denominator. So we can do that real quickly. 1/2 is the same as 4/8. 1/4 is the same as 2/8. And then 1/8 will just stay the same. So 1 divided by our total is going to be equal to 7/8. And then the last step, we just say if 1 divided by our total is equal to 7/8, then our total must be equal to 8/7. We just flipped over both sides. So we took this fraction and we flipped it over. And we took this fraction that it was equal to and we flipped it over. So our total is equal to 8/7 ohms. That's the total resistance in the circuit. And here, this is also, we're solving for our I total. So we're looking for the I total in this equation, or the total current before our electrons branch into its 3 separate branches. So now all we're going to do is, just like we solved any of them, we're going to come over to our equation here and we're going to say I total is equal to our 12 volts divided by our total, which is 8/7. Oopsies. Control Z. 12 divided by 8/7. And I'm going to pull up my calculator here. Should be able to see it. You're probably going to want to use your calculator on this assignment. 12 divided by, and I'm going to put 8/7 inside parentheses to make sure it is right. And I'm going to get 1.15 amps. Okay, so, well, that doesn't quite sound right. 12 divided by, oh, there we go. That didn't sound right. There we go. 10.5 amps. I didn't hit equals again. So 12 divided by a little bit more than 1, 8/7, gives us a total amperage of 10.5. So I total equals 10.5. So now you might be asking yourself, well, okay, that's great, but how do we figure out how much current is in each of the branches? Good question. So I'm going to erase this. Hopefully this makes sense. You can always stop this video and restart or whatever you need to do. But we've now found that our total current is equal to 10.5, and remember this is amps. 10.5 amps. So that's up here, I total. And now we want to know how much is going to go in each branch. So that part is actually quite simple. If we look at our first branch, it's just going to be the same thing. I equals V divided by R. So this is for our first branch. It's going to be I1, and then our voltage is the same everywhere, and then R1. So this is simply going to be I1 is equal to 12 volts divided by our R value, which is 2 ohms. So our current through the first branch is going to be 6 amps. Our current through the second branch by 2 is equal to V. And remember, the voltage is the same everywhere in a parallel circuit. So the voltage across all of these resistors is the same. R2. So that's just going to be 12 divided by 4, which is 3 amps. Bad equal sign, but that's just an equal sign, 3 amps. And then finally, I3, same thing, equal to V over R3. I apologize for my messy computer handwriting. I'm trying my best. 12 divided by 8, which is equal to 1.5. And if we add those three things together, we see that 6 plus 3 plus 1.5 gives us a grand total of 10.5 amps. So we now know the total current is 10.5 amps, and we also know here, I'm going to circle this with red, the amount of current going through each of these branches. And if you think about these numbers, it makes a lot of sense. There's twice as much current should be going through R1 as through R2, because R1 is half the value of R2. And same thing, twice as much current should be going through R2 as R3, because there's half the resistance in R2 as compared to R3, which same thing, 1.5 is half of 3. Hopefully that makes sense, you guys. please take your time with this. You might have to rewatch this video, or I strongly recommend Khan Academy does a really good job of explaining this kind of stuff as well. But yeah, go ahead and leave any comments or questions you have underneath this assignment, and good luck. See you guys later.